Good morning, everyone. My name is Genole de Keldal. I am head of the digital asset group in Clerical CIB, and today we're going to talk about the CAST challenge, and I'm going to introduce in this video the delivery versus payment use case for the CAST challenge. So the CAST challenge is the second edition organized by Société Générale Forge, with which we are associating ourselves, Clerical CIB, in order to promote a community construction of standards around the security issuances in blockchain. So in the CAST challenge, there is two use cases, and we are going to focus on the second use case, which is how to build an on-chain settlement between an asset and the representation of a settlement asset or cash. So in this video, we're going to cover the following items, and there will be more video to go deeper in some of these elements, and in particular the proposed standard that Clerical CIB has put in place, namely SOBOND and SOCASH, and we're going to talk about that on a second set of video. So we are going to first have a little brief on the principles for financial assets, then discuss about the representation of asset and cash. We are also going to explain what we consider as being an atomic on-chain DvP and what can be a DvP between two blockchains using hash time lock contract. And eventually, we are open for candidates to bring their own approach and their own solution with innovative suggestions. So, the legal framework of tokenized assets are different between the countries. So we all know that the legal framework is currently evolving in the various countries. There is the French framework that allows for a register of asset to be hosted in a blockchain rather than in CSD format. The Luxembourg law also, the German law, etc. But not all countries have the same setup. So that's something you need to consider, and you need to be in a position to tell us in which setup this kind of your proposition will be viable. We also would like to bring the attention on the fact that it's the DvP solution, although being a technical solution in the end, it needs to be clearly stated how you expect the users to be able to participate to that DvP and what are the externalities to your technical solution. In particular, if we are talking about settlement here, it's how the back offices in the various institutions are going to operate that DvP, what they need, how they integrate that with their potential internal system, etc. So obviously this is a challenge, so we do not expect a deep analysis or fully integrated solution, but we would like that you reflect on the rules and the business implications that your proposition will have. So what we expect in more detail on your proposed solution on the DvP is to try to give some high-level implication of the legal framework that you have chosen and why this framework seems to be applicable. We do not expect a detailed legal memo, obviously. We expect to that you look into that from an high-level angle. However, if it is in your expertise to provide such analysis in a more detailed way, that could be a plus in your proposition. Similarly, on the operational aspect, if you have the capacity to explain how your proposition will fit into the banks or the custody or the investor operational setup, it would be good because that demonstrates a better understanding of the implication, a better understanding on how your solution can be actually deployed. And obviously, the heart of the subject is to demonstrate the technical setup of your DvP. So this is a mandatory demonstration. We do not necessarily expect a functioning solution, but at least an explanation on how you're going to make it work. Obviously, if you can demonstrate with code, with prototype, it's better because obviously it demonstrates that it effectively works and it's not just on paper. Okay. So let's talk about asset and cash representation. Obviously, when we talk about asset here, we talk on very generic way on financial product typically that we are representing on chain. And we expect a focus on securities that are representing debt of an issuer, like bonds, obligation in French. So these assets are supposed to be represented using a standard. So this is the first use case. And this standard is should be using the CAST recommendation. And as we'll see in other video, we are also expecting you to look into the second representation, which is an extension of the CAST model that we have used in our recent issuance, but that is more close to the blockchain setup because we have chosen to use Ethereum on that particular implementation, that particular standard. On the cash side, there is several possibilities. And really, if we are much more mature on the asset side, the cash side is somehow something that is more under investigation by the various actors in the market. So there is the possibility to look at stablecoin, but you have to assess the implication of a stablecoin for the banking system. And there are other options which are representing cash bank accounts on chain. We have a proposition that we are going to discuss in a separate video, which is SoCash. This is what some call tokenized deposit, but I think it goes a little bit further than that. So we'll make a dedicated video to explain what we have with that. And obviously, these are only two probable solutions. If you have alternative, if you have proposition to make, obviously we expect you to come forward and to demonstrate what are the benefits of your alternatives. We are not necessarily listing here the CBDCs because it's a kind of stablecoin, it's a kind of mechanism that is managed by central bank, and central bank are not participating to that experimentation, to that challenge. So obviously you won't have that. However, it's important that you state how you would integrate interbank cash management in your solution, so that and if you would need the interfacing with a potential future CBDC or other interbank settlement system. So let's focus now on what we consider being an atomic on-chain DvP. So this diagram is a very naive representation of the mechanism, but just to give an illustration of what we understand as being an atomic DvP. So in the gray box, you have the representation of the scope of the blockchain. And as you know, in a blockchain, a state change from one block to the next. And we expect an atomic DvP to be in one single block, transferring the asset and the cash within the same transaction. is in the same transaction to ensure that it is done in a single block. So the representation here shows that the account A is transferring the asset to the account B, and within the same transaction, the account B transfer the cash to the account A. Obviously, account A and B are representing addresses of parties to the transaction. The green boxes, the dark green boxes represent smart contracts. So smart contracts that represent the asset on one side and smart contracts that represent the cash on the other side. And the DvP smart contract in the middle that is there to interact between this asset register and the cash register. And the mechanism that we expect you to design and to develop is to demonstrate that with this setup of a DvP smart contract, it's possible to control an atomic transfer of asset versus the cash while respecting business rules that are obviously expected. And in the business rule, you have to consider obviously regulatory requirements such as ensuring the beneficiary and the sender being authorized to do the transfer, but also making sure, obviously, that the balance are sufficient to do the transfer. And I mean, consider all the type of control that you believe are needed in such a transfer. So this is again the atomic on-chain DvP, which is transferring within the same blockchain an asset between two accounts and a cash between two accounts. That doesn't need to be exactly the same account. It has to be atomic between an account and another account, and within the scope of a single blockchain. Now let's look at the so-called hash time lock DvP, which in this circumstance consider that the assets are living in a blockchain on the left side of the slide, and the cash is living in another blockchain on the right side of the slide. The principle of the hash time lock, and I believe some of you know, and for those who don't and who wants to dig into that, there is plenty of documentation on the web on the HTLC mechanism. But as a matter of principle, the logic is that the two parties are actually creating each on each blockchain an HTLC contract that enables the unlocking by the receiving party of the asset or the cash through the sharing of a secret. Okay, so this is obviously a bit more complex than an on-chain and atomic DvP, and it cannot really be on-chain given that it cannot be atomic given that there is two blockchain, but at least it secures the possibility for two parties to be sure that the delivery and the payment will happen, or everything will be restored to where it was at the beginning. It's important to state, if you choose to demonstrate the hash time lock DvP, what are the limitations of such a process, and what could be the mitigants to those limitations? What are the risks that are involved with this type of mechanism, and why you have chosen to use such a process rather than the atomic DvP? The final point, obviously, is that if you have your own proposition for settling an asset against cash, obviously we are open to additional option, and we are looking forward for your proposal. Thank you very much. I'm going to close the video now, and we are going to meet again for other video more focus on what are the SOBOND and SOCASH.